My name is Logan, and I have the pleasure today of emceeing our developer track here. A couple quick reminders before we get started. If you haven't yet, don't forget to download the mobile app or visit the mobile site at awe.live, where you can find exhibitors and connect with other attendees. You'll also find the leaderboard here, where attendees with the most engagement on awe.live will win prizes. So don't miss the event wrap-up and Best in Show announcements on the main stage at the end of today. As you go throughout your day, don't forget to use the event hashtag AWE2021 when posting on your social channels. We always love to see how you guys are engaging with the event. A quick reminder that all sessions will be recorded and made available to all in-person and virtual attendees on the awe.live platform after the event. And finally, the expo hall is open today from 10 to 3 p.m., so be sure to check it out. All right, and to get things kicked off, I'd like to share a quick thanks to our event sponsors. The AWE team would like to thank our gold sponsors for their support: ArborXR, Care AR, a Xerox company, HP Inc., Meta Materials, and PlugXR. And a very big thank you to our titanium sponsors, Niantic, Qualcomm, and Unity. And with that, we'll get started with our first session. So let's welcome Dan Miller to the stage. Dan is a senior developer advocate focusing on the XR industry at Unity. He has over 10 years of experience in the gaming, content development, and XR industry, including 4 years at Unity. So welcome, Dan.
Thank you. All right. So it's been a while for a lot of people with presentations, but I'm really excited to be back and excited to talk to you guys today about updates with Unity, Mars, and AR Foundation. So my name is Dan Miller. I work at Unity Technologies as a senior developer advocate. If you're interested in XR content, mostly on the AR side recently, you can follow me on some of the social platforms at Dan Miller Dev there. So today, just to start off, kind of giving a high-level agenda, I wanted to start off by talking about, what is AR Foundation, what is Unity Mars, how they kind of play into the Unity developer ecosystem. From there, we'll dive into some updates to Unity Mars, talking about things like meshing support, as well as the different features that are available in the AR Companion app. You might have seen a talk earlier this week from my colleague Phil, going over some of the details there. Then we'll move on to AR Foundation, talk about some things that are happening as far as the package consolidation, the API restructuring, as well as diving into some latest features on ARKit, AR Core, and how we're focusing on head-mounted platforms. And then last but not least, I'll just dive into some general AR development tips. Some of these things are going to be kind of specific to Unity, but they're also just things to keep in mind as you're developing applications using AR, especially at a larger scale that are used for a longer time. So with that, let's go ahead and talk a little bit about AR Foundation and Unity Mars. So really at Unity, our idea has been for a long time, build once and deploy anywhere. And originally, this was kind of the main use case on things like mobile platforms, console platforms, and just the variety of different platforms that we support. And this is something we've tried to really carry through in the XR space as well. So at the bottom there, you see all the development platforms and partners, from the hardware to the SDKs. And on top of that, you have what we call our XR provider framework. So this is really the native integration that we do on the Unity side, working with those partners. And you as a Unity developer see those as packages within the package manager. Now on top of that, this is really where we get into things like AR Foundation and Unity Mars, and this is in our developer suite. So we see this as kind of a connected layer that allows you to build on top of those native integrations and use a variety of different features or options from this developer suite. You might develop an application solely using AR Foundation. You might use Unity Mars and the companion app and utilize that being built on top of AR Foundation. And the resulting content is, games, experiences, industrial content, really whatever you want to build utilizing those different layers. So at its core, AR Foundation is a cross-platform framework built as an abstraction on the different platform providers. So originally it started out focusing on ARKit and AR Core, and it was looking at both the unique and shared features on these platforms. So you think about things like plane finding, hit detection, device tracking, and really there was a lot of those commonalities. And so what we did is we built this framework so that you as a developer can target a single API. And then if you output and build your device to an iOS device, we'll hook up ARKit in the background. An Android device, we'll hook up AR Core. And the nice thing is that really with AR Foundation, we're covering both those common functionalities and the unique ones. So ARKit added things like meshing support, and that's available within AR Foundation. The way we've structured the API is that if a new platform adds an additional feature, or if it supports that, we can kind of hook it up behind the scenes, and then you as a developer target features, not platforms. Now, Unity Mars is an additional layer kind of on top of AR Foundation. You can provide other what we call provider frameworks into that, but really it was built as a unique set of tools and like functionality really on top of the Unity AR Foundation as well as the Unity editor. So this is looking at things like providing a simulation layer or a simulation view, and that's what you see in that screenshot there, which is looking at giving you different environments that you can start to build and test your content against. There's also a lot of unique features and APIs for things like multi-surface detection, determining how and where your content spawns. And then we're also seeing additional things like the companion app, which I'll talk about here in a bit. Now let's go ahead and dive into some updates specifically to Unity Mars. And these are coming in the 1.4 update. So the first one is meshing support. This is something we've heard a lot when the ARKit LiDAR-enabled devices came out. And really what it does in Unity Mars is it gives you the simulation environment and allows you to utilize the meshing functionality. Now, a couple things to note here is you'll see that currently it doesn't interact with what we call the Mars database layer. So this is the layer where you'll query things like surface size or how big it is. And instead, it just gives you the mesh at runtime as well as the semantic understanding. So here we see just a view of the normal simulation view within Unity Mars. And here we see it overlaid using the mesh. Now, something to note here is that in the implementation, if you think in terms of Unity, we have the mesh renderers. Here we're just duplicating the mesh renderers. So you see the mesh kind of as a one-to-one replication, but it has the different materials applied to it. So again, this is what it looks like in the normal simulation view. Here's with the meshing enabled. And here we're using the semantic understanding to kind of tag these objects differently and apply different materials. So you can see the floor has a little bit different material than the table, the chairs, the wall, etc. Now, what this looks like a little bit on device is going to vary depending on the device you get, as well as kind of the mesh density that you might see come through on that device. So here's a real-world environment. We have a desk, computer, chair, etc. And here it is captured on an iPad. So you can see it's it's a little bit, it's not that one-to-one which you see within the simulation view, but you can see the different semantic understanding. You can see kind of the tagging as those materials are kind of adjusted here. And there's different solutions for things like a triplanar shader for basically adjusting the material or the texture depending on what the semantic understanding picks up. Now this is supported on ARKit LiDAR-enabled devices, so that's things like the iPad Pro, iPhone 12 Pro, iPhone 13 Pro, as well as the HoloLens 2 device, which also has meshing support. The next big update to Unity Mars is the AR Companion app. So this is an evolution. When we first kind of put this out, it was called the Mars Companion app. And really, we've broadened the capabilities of it and what it covers. And so we're kind of rebranding it here as the AR Companion app. Now, what it initially was tackling and still kind of allows you to do is what we call this on-device authoring for Mars. So you can go through, you can basically scan around an environment. So you have a runtime app on a mobile device. And from there, you can detect different surfaces, place content, and author proxies as if you were in the Mars editor. Now, all of this is kind of saved and synced through the cloud. So in the cloud, you can download all your captured content from the companion app, start to iterate on it, and build within the editor itself. It also covers different things like what you see on the left there, which is a tool for the Mac OS Object Capture API. So it allows you to take basically high-resolution pictures. You can kind of map out the object, bring that back into the Unity editor, and use the object capture tool there as well. And it also allows you to record session data. So you can record both a video as well as planes, point clouds, etc. And then bring that back into the editor and continue to iterate it on it as well. And that's really helpful for things like when you're building a location-specific experience, you might only have access to that location for a little bit. You can go through, capture different data, capture videos, and then bring that back home and continue to iterate on it by syncing it to the Unity editor there from the companion app. So shifting over, I just want to talk about some updates to AR Foundation. And again, I wanted to emphasize that while Unity does provide some additional utilities on top of AR Foundation, we're not really providing unique features outside of what the platforms themselves have. So, if you look at something like meshing, for example, that's a feature that Apple has enabled on the ARKit platform. And while Google has some APIs that are similar with depth on AR Core, we're not going to implement, a brand new feature like meshing on the AR Core platform. Now, some of the updates that we've been doing on the back end is what we call package consolidation. So this is really kind of restructuring some of the APIs. You can see these AR subsystems and the face tracking packages. Those are actually being deprecated. So this is what it looks like currently in AR Foundation 4.2. And in AR Foundation 5, we're just kind of consolidating those. So there's still kind of a stub package there for the subsystems. And just from a development standpoint, it's just kind of changing some of the namespaces for the different functionality and how you access those features. And really, it's just consolidating things to make them a little bit more tightly knit, having less dependencies on some of the various packages and things. So, face tracking on ARKit's not going away. It's just being rolled into the ARKit package as a whole. Now, if we start to look at some of the different platform-specific features, these are, these were announced a bit ago, and they are available in AR Foundation, and these are some of the most kind of recent features that we've seen within the platforms themselves. So depth is a big one on both ARKit and AR Core. Here, what you're seeing in this GIF is just utilizing that runtime depth data to kind of control the fog fall off here down a hallway. There's also device support. So we have support for all the latest devices with the iPhone 13, iPhone 13 Pro, iPad mini, etc. And then there's also been some updates with face tracking. So this is allowing you to track up to 3 faces with the front-facing TrueDepth camera. Also things like simultaneous back-facing and front-facing camera tracking. So you can actually do plane finding with the back-facing camera and then pull in data or capture data using the front-facing camera as well. On the AR Core side, so one of the big features is recording and playback. So this is actually a little bit similar to what's happening on the AR Companion app side for Unity, and this is specific to AR Core. So what this allows you to do is go through and capture a video of your AR session, and what it does is it embeds a MP4 with an additional stream of data. So this is things like when planes are found, certain anchor points, etc. And again, this was really helpful for things like a pandemic where you could only get access, maybe you're making a museum experience, you can only get access to that area once. You could go through, capture various videos of that area, and then iterate on that video using that additional data stream that was kind of embedded in the MP4. So the cool thing here is that it needs to be captured on an AR Core enabled device, but it can actually be played back on a variety of different devices. So it can be iOS, Android, Mac, PC. And then AR Core can simulate the APIs on top of that video recording, so you can start to iterate, offline or not in real time when the data was actually captured. The next one is a performance overlay. So this is something that Google's done just to give you a lot more information about what's happening on your device. So this gives everything from native callbacks with like Java memory, CPU performance, what's happening there. And I do have a small note down here that AR Foundation, obviously maintained and developed by Unity, and we have and maintain the packages. So we have the AR Core package, the ARKit package, and Google actually maintains something called the AR Foundation or AR Core extension package. And this is built alongside of us. It helps Google iterate a little bit faster. We work collaboratively with them, and that's where they actually enable some additional features. So there's some additional utilities for recording and playback, allowing you to kind of play it back on your device a little easier, as well as things like this performance overlay. So it's all built kind of on top of AR Foundation. There's just an additional extensions package there, and that can be added via the package manager with a Git URL. And if you're curious about that, there's lots of great documentation from Google. You can just search AR Foundation extensions to get access to that. Now, one of the big things we've heard a lot with AR Foundation, and what all of us have seen here, is that there's a lot more emphasis on head-mounted platforms. Now, at Unity, for a while, there was a little bit of a disconnect of how that data got in or how AR Foundation handled some of the data from the head-mounted platforms. And I'm excited to say that really the way we're going in the future is we're looking a lot more closely at these head-mounted platforms. So a lot of the capabilities like meshing, device tracking, light estimation, those are all shared on the head-mounted platforms. And now we're routing that data through the AR Foundation packages. So with the latest AR Foundation 5.0 and moving forward, the head-mounted platforms like the HoloLens 2 you see here are starting to become kind of the full development and test suite that we're doing on the back end. So we're making sure that all these features work, we're extending our samples and things like that. And I think this is really where we're seeing kind of the future of AR Foundation. So making sure that it's not just the mobile devices, it's also supported on current and future head-mounted platforms as well. So the last thing I wanted to talk about here with AR Foundation is just AR Foundation 5.0. So this is coming, if you grab the latest Unity 2022.2, it's a lot of twos, you can grab the AR Foundation package. It is going to be backwards compatible with Unity 2020. And one of the features we've added here is just a debug menu. So it's actually pretty similar to that performance overlay, which we're seeing on the AR Core side. But right now, we're just looking at kind of enabling or visualizing different elements within AR Foundation. So we have a small video here. You can see that on the right. So what we've done is we've actually visualized the origin. So this is kind of information about the AR tracking session. So you can see a little gizmo in 3D there. There's a little kind of UI menu off to the right. We can also toggle or enable things like plane visualization. So this is basically outlining the plane there. You can see we have kind of a feathered shader, so you don't see the full edges of the plane, but you can kind of toggle that back on and off. Let's see if we can play it again. Whoops. So you can see there, it's like the red outline for that. And really what we're going to do is just start to pull in more features here to give you this overlay on kind of just debugging and understanding what's happening. We have things like frame rate and additional data there for point clouds, et cetera. So this is just a debug menu. It's going to be in the AR Foundation samples repository and allows you to just add to your project, get some additional information to kind of understand what's happening. Now, the next thing I want to talk about is just some kind of general development tips and tricks. And a lot of these I've learned and experienced from working on kind of larger AR projects. Now, in the past, I've done a lot of demos that are kind of small one-offs. I make the demo, I work on it, I run it for 30 seconds, a minute, a couple minutes, and it's done. And really, as you start to build these larger scale AR experiences, you understand that at the end of the day, this is taxing on the device. Depending on what features you're using, you'll start to see things like heat, battery drain, et cetera. And there's lots of kind of small things you can keep in mind when developing these AR experiences. So first, starting off, just some kind of general things to consider. The first one is only enable the features that you need. So the way AR Foundation or the AR frameworks work is that you have an AR session, and that AR session has an AR configuration. Now, this configuration is a makeup of which features you have enabled, and there are kind of a limited number of configurations that's possible. So some features, if it's enabled, you can't use another feature. And really the idea here is make sure that you only use the features you need, or you only use them when you need them. So if you look at something like the mesh support, you can enable that by default and you can start to get meshing, or you can actually kind of enable or disable that at runtime. So AR Foundation has these managers, so there's an AR Foundation or an AR mesh manager, and you can disable or enable that when you need it. And you could do this with a variety of different features. The idea being that once you disable a feature, that configuration gets updated at runtime, and you're going to be kind of taxing the device a little bit less because you're just doing less stuff. The next thing is AR devices are mobile. So this is something I'll kind of touch on with a variety of different points, but at the end of the day, you're on a mobile device. Even the head-mounted platforms, they're still mobile. There's a battery attached, there's limited compute, and just keep that in mind when everything from kind of authoring what sort of content you're making, make sure it's low poly, limited texture maps, et cetera. And then last but not least is when are you tracking? So a lot of the demos I've made in the past, I hop right in, AR Foundation's tracking right away, it's showing off a specific feature. But when you look at some of these larger games and experiences, things like Pokemon Go or Pikmin Bloom, they have a full interface and a menu, and you dive into the content, and then you enable AR in the experience. So think about, do you always need to be tracking? Are you showing a full screen window? Can you pause the tracking for a certain amount of time, depending on kind of what UI is up and things like that. And that obviously depends, a bit on what type of application or experiencing you're making. So next, I just want to dive into some kind of general optimizations. So the first one is reduce draw calls. Think about the number of different materials you're using. Can you start to batch some of those materials? Are there lots of different material variants? And again, this is kind of on the Unity side, but more kind of general to mobile development. The next is pool assets. So if you're instantiating or deleting lots of things at runtime, is it easier, or do you need lots of different assets? Can you spawn things, 10 things at the front, and then kind of enable or disable or position those how you need them? And this actually goes into the watch out for garbage collection. Basically, Unity is going to kind of do different garbage collection depending on how you're managing your objects or managing some of your memory. And depending on what your application does, say it's you're trying to record the screen, or you have an important moment in your application, GC can cause certain hitches. So you might notice like some of the content shift around a little bit, or when you start to drop frames, that'll be pretty noticeable. So that's just something to kind of consider or keep in mind. Additionally, when you're kind of spawning and deleting lots of objects. The next one, and this is actually a big one, it's something I hadn't really considered, but as we see more and more devices come out, and this is render at a lower resolution. So at the end of the day, lots of new devices come out, and the reality is that they just have higher resolution. So you're rendering a lot more pixels, and depending on your experience, you can lower that down. So you can, I'm working on an application, we're lowering it down, and we're rendering it at 1080p. The reality is, most people, it's still a really high quality experience. That's still a really high quality video feed. The screen does a lot of the heavy lifting. It still looks great. But just something to consider, especially in these longer AR experiences. And when you're using the device more, lowering at a lower resolution can help kind of save performance a bit there. And this also plays into the lower the frames per second. So by default, ARKit is going to render at 60 frames a second. ARCore has some devices that can render at 60 frames a second as well, but most of the devices on ARCore side is going to be 30 frames a second, and you can just cap this down to 30 frames a second for ARKit as well. Now, I wouldn't recommend going lower than 30 frames per second, and you are, again, going to see a little bit of lower quality, similarly if you lower the resolution, but that's just kind of something to keep in mind there. And then last but not least, keep the texture lookups low. Again, think about doing things like combining textures into a single map, having a shader that does like channel lookups and things like that. And really that's just kind of looking at generally optimizing your art and production pipeline to use less resources as the AR content or the AR systems are using a lot of resources for themselves. All right, so just to quickly wrap up here, so AR Foundation, Unity Mars are really part of this XR development suite that we're developing here at Unity. And really it's looking at kind of giving you tooling for speeding up your iteration and process, as well as reducing fragmentation across the different devices and ecosystems. Now, there's been some minor updates on the platform side when you look at things like ARKit and ARCore. Of course, we work closely with those partners, and when they release new features, we integrate those to AR Foundation. Head-mounted devices are becoming much more of a thing within the AR Foundation ecosystem. We're going to continue to support them, but we're going to make sure that that data feeds through the AR Foundation APIs, and that becomes an additional build target for you. And last but not least, just consider mobile optimizations when developing AR content. There are limited resources on these devices, and there's lots of things to kind of consider, especially when building these longer or larger scale AR experiences. All right, and with that, I think we have a little bit of time for questions. Thanks.
All right, thank you. We've got time for one question. Anybody?
Thank you so much. I have a question with regards to if our phones today have enough power to do multiple things. So for example, to have AR Foundation running, but also to have hand tracking happening at the same time. So say that you put the phone in front of your eyes as a display, and you have AR Foundation running, and then you have, for example, Google's Media Pipe tracking your hands and whatnot. Do you think there is still enough power on our phones to do full-on experiences with hand tracking and AR Foundation running at the same time?
Yeah, good question. So the question was around basically utilizing AR Foundation with additional libraries or capabilities with things like hand tracking. So it's hard to give a definitive answer there, especially when you think of just general phones. Now, if you're on the latest Pixel or if you're on the latest iPhone, you're going to be able to do more. I have experimented and seen some additional utilities happening alongside AR Foundation. So AR Foundation does give you the ability to extract the camera image directly from the CPU. So that's for feeding it to things like machine learning libraries. The general tip I'd say is, if possible, use the kind of on-device or the native libraries for that. So I've seen some things on the AR Foundation side on iOS, so with ARKit and with Core ML from Apple. So it can play around and you can get enough performance for things like that, but it really kind of depends on the device itself, and if possible, using those kind of core libraries are going to give you more performance than kind of an additional utility. So. Yeah, but yeah, thanks a lot. I'll be around for most of the rest of the day today. If you had some additional questions and things like that, you can come find me. Thanks.